request our guest of honor, Shri Kumar, CGM Sir, to kindly address the gathering.
Good afternoon, everybody. It was a very fruitful get-together, especially we being on the threshold of making a good impact on the project space. There is a vital need for the good vendors, relevant vendors, who can supply us the goods and services at an economical price, as well as addressing the environment, and we can take a step towards environment-friendly steel, or so to say, the green steel. I think there are 6 presentations. How many presentations are there?
We have to do 10 now.
10 presentations. In fact, many more presentations were there, but because of the paucity of time, perhaps we could not accommodate all the presentations. And I congratulate the entire team of organizers who have organized such an occasion, which is normally a rare occasion. So many vendors participating at one venue is difficult to have, especially at a place like in Bhilai, which is relatively a small place. But then, with respect to the steel production, it's a very big space. And now I request Madam to please take it further. Thank you very much.
Thank you, sir. I now request our chief guest for the day, Shri Tapas Gupta, CGM in charge Iron, to kindly address the gathering.
Good afternoon to all. Respected seniors, colleagues and suppliers. One thing, I will not take much time because time is already short, and for 10 presentation it is only 3 hours and 3 to 3.5 hours remaining at present. So need to be short. One thing I will only tell that in last 1.5 days discussion, we could find that if you go for decarbonization part, then there involves initiatives, innovations and cooperations. All the 3 should go together. That cooperation part is the last session of this conference. So we will help. We will hope that cooperation will get from ancillaries, from suppliers, from customers, and so that our decarbonization drive will be successful. Thank you all. Let us go for the actual presentations. Thank you.
Thank you, sir. Without much ado, now we'll start with our presentations. I request the first team from Cargo Projects to make their presentation.
We are supplier of AC, and you all know in the AC we are using the refrigerants, and now there are a lot of technologies in the air conditioning wherein we can develop the machines with the refrigerants which can be more eco-friendly, which can reduce our global warming, and most importantly the ozone depletion layer. The air conditioning part in the entire steel plant is very small, but बोलते हैं ना बूंद बूंद से सागर बनता है, वैसे ही our AC will definitely help with the new technology to reduce the decarbonization. So myself Chetan Shape and he is Raj Kasade. We will take through all the presentation. This is the content. Because short of time we may run in little faster. Sorry for the same. About Kabu Projects, the Kabu Projects Limited is our company name, located in India. The important part of our company is that make in India but with the German technology. Atmos is our brand name. These are the various industry grade air conditioners which we can use in the high applications. This is our factory in Noida. The specialty of Atmos. Why Atmos? The Atmos AC can work up to the temperature of 90 degrees Celsius, which can be used in SMS, steel melting shop, your hot stick mill, coke oven. So all the steel applications we can use our atmos machine without any hindrances. These are the various components. Most of the components we are using in the air conditioner are with the latest technology and are of the very good quality in the world. So for our product, don't worry, we are there to provide you one of the best product in the world, and that too with the most eco-friendly equipments and components, including refrigerant. These are the heat exchangers. The important part of the atmos is that whatever machine we are making in-house, we are testing in-house only. We are keeping all the stringent conditions like temperature, 90 degree. We can maintain that temperature at one room and test our machines so that you will get the machine with accurate performance. These are the various components. What are the specialty is that our AC can work, as I said, in the high ambient temperature up to 90 degree. Also, in the most dusty environment, our AC can work without any hindrances. And for the very stringent conditions like coke oven, where various gases are there, in that stringent condition also our ACs can work. In the vibrations, also we are taking care of with the help of design कि any kind of vibration will not affect the performance of AC. We can use stainless steel plates also as per the application. Now, next part is the decarburization that my colleague Raj will take through.
Thank you, Chetan, and very good afternoon all here, present dignitaries and colleagues and friends around. Now, I will quickly take you to the presentation for what we have gathered here today. Decarbonization. The word itself says that we need to minimize the carbonization. Now, the basic part of it is to understand is we cannot eliminate carbonization. We also breathe CO2 out. So you can't eliminate, but what we can do in purposefulness is we could minimize it. Now, why we need to minimize it? Yes, we need to understand. So, I'll give you a brief about why background of a refrigerant. See, previously there were ACs, but the refrigerant, those were used were of water, air, natural resources that were available. Then efficiency was a question, and even the temperature, variation in temperature was a question. So based on that, the development started building on, and these refrigerants started coming up. Now if I wanted to split this part, I'll split it in three. First is the old ages one, what I discussed about. Second is middle. In medieval stages where it start combination of both. That's how we have a package ACs, a water run package ACs. We all have in steel plants, there are many packages around. But at this point of time, we got to know that there is a change of trend. And we need to adapt again into air and ACs. So that way, this is the background of an ACs. There were previously such kinds of refrigerant were available, R124 and all. But understanding the carbon footprintness, the modernization started off, the technology emerged, and there was a necessity to change this trend and minimize the carbonization. So advancement in here is, basically advancement is nothing but the blend. We pick something from here, something from there, we blend and try to get maximum output of a thing. So these refrigerant were developed in such a manner. Now currently what we are delivering is 450A, refrigerant R450A, which is least carbon footprint refrigerant, and at the same time we can utilize it to the ambient temperature of 90. So this is how the trend was set and the development started on. This is how you can see right away from 1930 it began and the story is still going on. In 1985 there was Vernalization in Montreal Protocol. There was a stage where they realized that this is a troublesome and it has to be taken at a warfare level, understand the problem and get solution to it. And this is how we all know that ozone layer is getting depleted. CFC gases and all gases are the responsible sources for the depletion of ozone layer. Now I need to cover and control and safeguard ozone layers because of the UV harmful rays that comes to us, and it is not preferably good for our human health. So basis of that we wanted to safeguard it. So how we could do it, this was the reason coming up. And these were these responsible people and the conference around who actually started implementing protocols, who started implementing laws to regulate these things around. solution actually is, like how we justify this could be a refrigerant useful. These are a few names that has been highlighted and what we use currently. R450, as I have described, which has a capability to range up to 85, actually till 90 we have tested it. R503 is a new upcoming. R134 we all know, everyone rents car. In car the refrigerant what they use, we call it eco-friendly refrigerant, that is R134A, but even this has carbon footprint. So this trend of minimizing it is making us work for it around and get an optimum solution and replacements to these existing refrigerants that we are using. So currently 450A is the beneficiary what has been recognized as of now. This is a few range just to understand how it works. GWP is global warming potential and ODP is ozone depletion potential. So these are the refrigerants. If you can see R134 as I rightly told you, the carbon footprint for it is, the global warming potential is 1430, and also it has a ozone depletion potential of, you can see here on the figure. So how we choose, what is the necessity phenomena to understand and choose a refrigerant? It bases on the following factor you can see. First, environmental impact. Second, safety. Then, cost effectiveness and energy efficiency. On basis of these, we choose a refrigerant and then it is made to work. This is how our contribution towards decarbonization from 2016 onwards. This is what we can see. And so on and so forth, we are still developing. Our R&D is strongly putting up every effort possible to get a maximum output from these refrigerants. Now, these are few policies that have been made globally, so to safeguard that I have discussed already. These are the protocols that have been already working along. Now, contributing to sustainable development, what we are doing. Environmental friendly refrigerant are used. We are trying our level best to lower down the GWP value. Like previously we used to use 227EA, but now it has been replaced with 450A. So this is how we can understand how important it is and how we are doing it. These are few models that we have already employed. These are working under this symbol. And we proudly say, you can remember us when there is maximum dust. You can remember us when there is maximum ambient temperature and we will not let you down. Our machines are already running in the rigorous areas of sale, coke oven. So if our machine is sustaining that area, that environment, it can run anywhere around the sale, anywhere around globe. This is what we have developed, a recent trend where you are sitting in the conference and you can on your phone check how the functionality of the machines are. So this is the recent development we have done. These are our plans that we are scattering so far around globe. So basically what my last statement is, to conclude this, we encourage all stakeholders to prioritize the adaptable of sustainable refrigerant practices.
Just 1 minute I will take. My earnest request is to all of you, we are ready to innovate in terms of R&D, innovation for developing the machines with a more eco-friendly refrigerant. But what we are finding as a customer, you are trying to keep the old refrigerant machine because of the inventory purpose. I do understand you want inventory, but we need to now think about whether we need to save the cost by doing the inventory or we need to really save our environmental. Earnest request to go for the machine with the new refrigerant. Thank you all. Thanks.
Thank you. I would like to inform all the teams which are presenting that we will be giving a total time of 10 minutes to you as we had already communicated. And at the end of 8 minutes, the first bell will ring, and at the end of 10 minutes, the second bell will ring. Request you all to also kindly adhere to the time limits, and we'll have a question and answer session at the end of all the presentations of session 1 for 58 minutes. So I welcome our next presenter from team of MACO.
From MACO Corporation, it's a pleasure to be here to present some insight of our company. MACO Corporation is present in steel industry, and we believe in building relationship. We have a short time, so we will start the brief introduction of our company. Macro Corporation is a 57-year-old organization, and we have 700 employees people to serve the core industry of India, GCC and GCC regions. Representing over the 20 leading overseas manufacturers, Macro has also established 6 joint ventures and global manufacturers, focusing on the production and sales in India and GCC regions. Our mission is rooted in building a lasting relationship. Over the year, we have grown into the leading player in providing a turnkey project solution for the steel industry. We proud ourselves on offering the marketing and after-sales service to American and European manufacturers with a strong commitment to innovation, quality and ensuring the customer satisfaction. Our joint ventures are Copper Macro Service Private Limited. We offer the roller press, and second is the IMS. IMS is the IMS Macro Service Private Limited. Third is the Sibre Brakes. We represent here. Our joint venture is there. Fourth is the Metal of Macro Engineering Private Limited. In situ machining services providing. Desmet Design Private Limited. Marketing, and the last one is the Slater Macro. Just brief introduction of our product. The Copper Macro is offering the product hydraulic roller press and high pressure grinding rolls. The basic is that the application for the Copper Macro is the briquetting and the compaction, iron ore grinding and cement grinding, clinker grinding. IMS Macro offering for the measuring system for roll mills. The thickness profile measurement, width gauge and coating gauge, temperature profile and surface inspections. Sibre Brake, our product is that the service and energy disc braking system. Basically, we offer for the braking system in the cranes. Metal of Macro offering for the in situ machining and services. Desmet for hot metal desulfurization solutions. Slater Macro is established in 2021 for the rail welding line. Our product is the mobile rail welding system, stationary rail welding system, and application for the flush bed welding machine, welding in the railway. Yes, it's supplied in URL. We offer a diverse range of the product to the steel industry, including the rotary union, doubling make rotary union, LTEC automatic scuffing machine for the hot, warm and cold steel. Oxy cutting machine for the continuous casting machine, CCM. Grid project, we are providing the grid project services, electromechanical and robotic machine, marking machine. Main machine is that the marking machine, which is for the slab, billet, bloom and other rolling mills, holes, strips, plates. Forge rolls for the rolling mills. Jore make coupling and spindles. Our product is that the coupling and the gear spindle, barrel coupling. Jeeves, cardan shaft. maybe laser welding machine, CO2 and solid state type for the coil joining. Cobra neck hydraulic buffer. Formosa industrial gearboxes. Genie articulating telescopic boom and scissor lift. Our product range is aerial work platform, scissor lift, articulating boom, telescopic boom, and maintenance platform. Ansul make fire suspension system. Fire suspension system for the metal processing equipment. The project division of the MACO was established as a part of our diversified activities, focusing on the technology sourcing, procurement, planning, project management, and implementation in the collaboration with the world's leading technology providers and OEMs. Our project division enjoyed continuous access to cutting-edge know-how from those global leaders, ensuring that we offer only the most proven designs with the state-of-art technology. Additionally, our manufacturing unit and the local infrastructure allow for the indigenization of the non-critical item, improving project timeline, reducing cost, and fulfill the recent government policy of Make in India. Some of our notable projects include the rail welding line. I will show you the rail welding line, refinishing complex, roll and repair shop, installation of high pressure primary descaling unit, hydrogen bale annealing, skin pass and cell bocage plant, tension leveling and inspection, slab marking machine, replacement of petrol and straightening unit of billet caster, replacement of mechanical shear by oxy fuel gas cutting, and Central Research and Control Laboratory for NISP, NMDC Nalanda. The rail welding line for 260-meter long rail at Sale Bhilai Steel Plant. It's rail welding line installed in the URM area in Bhilai Steel Plant. Refinishing complex at Sale Bhilai Steel Plant. It's include the two packages, package 1 and package 2. Package 1 for mainly equipment supply, installation and commissioning, and package 2 for the PEB. What I think, sir, PEB pre-engineering welding. It's first this type of fabrication unit. The pre-engineering welding is supplied by the MACO in a sale area. Roll and repair shop at Bhilai Steel Plant. In the URM area, the carbide preparation unit, carbide blade preparation unit is supplied by the MACO Corporation. Complete installation and its installation commissioning is done by the MACO Corporation. Installation of high pressure primary descaling at plate mill of Sale Bhilai Steel Plant. The project is right now is in a execution part. Right now execution area. Hydrogen bale annealing furnace at Sale Bokaro Steel Plant. Skin pass mill at Sale Bokaro Steel Plant. Tension leveling and inspection line at Sale Bokaro Steel Plant. Slab marking machine in CCS at Sale Bokaro Steel Plant. Replacement of petrol and straightening unit of the billet caster and Sale Durgapur Steel Plant. Replacement of mechanical shear by oxy fuel gas cutting torch by billet caster at Sale Durgapur. Central Research and Control Laboratory for NISP. Complete laboratory installed by MACO Corporation. All the equipment supplied and installed the laboratory equipment. Our customers. Our footprints, we have 10 offices in India as well as the USA and Middle East and Bangladesh also. Thank you. I conclude my sentence. In conclusion, Mako Corporation is not just a company, it's a trusted partner for our clients, a leader in our industry, and a responsible corporate citizens. We are excited about what the future holds and look forward to collaborating with many of you to achieve shared success. Thank you very much.
I now invite the team from Champion Ceramics to make their presentation.
Friends and delegates. Say, I am one of the members of the champion team. I am Sapun Garai, the technical director. Say, I will be speaking on the subject as mentioned. You are all aware that refractory cost is only 3 to 4% of the total steel making cost. But it has a big role to play towards availability of converter or ladle for continuous steel production. So what I will be speaking actually, and magnesium carbon is being used in converter and ladle, and here carbon is one of the constraints. So the topic of decarbonization also suits to this thing because it is made out of carbon, the magnesium carbon. So what I will be speaking actually, I will be telling you some of the achievement and what we have done. And then finally, how we have got this achievement. That's what I am speaking. Now, I will speak some of the performance highlight. Say, the recent what is going on actually, we have lined the magnesium carbon peaks in the converter lining of ISCO, that is a 150 ton converter. And it is still in operation. Present life is actually 7,825. And the important point to be mentioned here that this we have done without any cutting. I mean, it is just operating without, just by a packing mass which we have developed. And they have a laser profilometer, and we are measuring the thickness after every heat. So at present, what we have found out actually, out of the total thickness of 750 millimeter, it is more than 400 millimeter is still remaining, and they are targeting a life of more than 10,000 hits at this moment, and it may go further. Now the converter, I will tell little detail about the converter lining and ISCO. This is the converter lining design. We have designed the lining. It's a single big lining. In the knuckle area we are using about 11 millimeter bits, and the 2 millimeter of 70 millimeter. They have 6 parting elements. This has been designed by us actually. And these are the type of refractory what is being used at different zones. But the most important thing to be mentioned that actually the HMR, the hot furnace of rupture, that is a state at elevated temperature, that is around 140 kg per centimeter square, which is one of the highest we have achieved. Now this is the bill of material actually, and this is the total bill of material. This is the basically the sleeve actually, block and because the taphole sleeve what is being used. So earlier the target life of this converter, the guaranteed life of 3,500. The highest life they have achieved actually is 5,800, and as I mentioned, it is running around 7,800 hits. So we have targeted some amount of some number of sleeves, but as the life is going, we are supplying the sleeve. The sleeve life is around 100 hits actually, and this is the parting element. It is a basically directional road parting element. What is being used? They have 6 parting element, about 1.8 millimeter, and this is being used, and they have used up to 3,000 hits. The top and bottom ring after that converted into the normal top ring. And this is the laser profilometer what is being used, and this is the graph actually that you can find out actually the taphole thickness as I mentioned, and the charge part it is 343 millimeter, and taphole is 377 out of 750. This is the bottom thickness actually what we are getting. It is varying between 1359 to 1751, and this is the we are measuring the bath height measurement actually, along with the lens position and the total volume is being maintained. To maintain the H/T ratio. And other places what we have supplied actually, This is basically in RINL we have supplied actually 3 lateral set. We got 4728 and the second one is in operation 2661 and third is yet to be line. In RSP 150 ton converted SMS2 we have supplied and we got 4884. In SMS2 BSP the converter has been lined in converter B. It is to be started operation on the first week of September and we have received 2 sets of converter order from the steel plant. Now this is about in brief or 2 minutes about the performance highlight. This we have achieved in Bokaro, the straight line about 105, about 60, 67 and 105 and then others I will tell actually this is about Visakhapatnam and JSW plant and other we are supplying to JSW, we are done to Dolby plant, we are supplying to Salem Steel plant. I mean this way we are doing to almost all plant actually, but if, with all this I will not go much detail, I will come actually why we got the record line. That is what is very important. You know the quality assurance measures what we are taking actually so that we get a consistent line because steel makers they do not only fluctuate in the converter line. There was a consistent life both in converter and ladder. So that what we have done. So I was speaking on that. So you know generally when we procure the bricks, we go for normal cold crushing stain porosity. But what is more important is the after because the converter is treated and you get the carbon is going and then you get the coke crushing stain, the coke porosity. And more important will be the slack portion and then the thermal shock resistance and then optimization of the residual carbon. So what we are doing, because for magnesium making, so selection of, there are 2 major components, magnesia and graphite. So while selection is the magnesia, what is very important is not only MgO, the impurities plays important, like the lime silica ratio, it should be more than 2, so that you can produce dicalcium silicate and tricalcium silicate. Similarly for aluminum iron, we have a limitation. And another important is the crystal size, because you know, if you have a company, you have different type of magnesia like seawater magnesia, natural magnesia, synthetic magnesia, and then fused. We are using fused, but you can see the lime silica ratio more than 2.5, and the crystal size is more than 500. In other cases, you get only 100. Because once the crystal size is more, it gives a high corrosion resistance. That is one of the reason we are getting lime. So here you can see by increasing the crystal size from 70 to 100, there is a drop in the erosion by 9.5%. And if you compare the defined quality of magnesia, the quality and the MgO is same almost 97-98, but the crystal size is different. So when you get 500, you get a high corrosion resistance. Now other component is the carbon. So here people are going with 96%, but what is important is the ash content. It should be at low ash and low volatile. And we have done some experiment like the flake graphite. If you use smaller size, it gives more corrosion. If you give higher size, it gives the thermal shock resistance. We are making a combination. So we have done the slack corrosion test. Basically, we take the defined composition and collect the slack from the steel plant, and then we do the slack corrosion test. You can see the less erosion means it's a better quality compared to maximum erosion. We have done at 1623 hours, and the conclusion is higher MgO and higher crystal size that gives the best result. This is the thermal shock resistance, it's a dynamic test where you can put the magnesia carbon deep into the furnace, induction furnace, and then you can find out what is the crack, different type of crack and thickness. From there you can find out. And this is about the thermal shock resistance test. You can see the binder is the important play. Binder 1 is giving a lot of crack, binder 2 is not much crack, but we are using by combination of binder 1 and 2. At this moment, I must mention that our plant is situated in Champa. We are having we are producing at present 3,000 ton of magnesia carbon bricks. Our turnover is about 450 crores now. This is one of the most important thing, the oxidation resistance. We do test the oxidation resistance test. The more white area is oxidized, the black is not oxidized. The more the black, it is better. And for that we use some special antioxidant. This you can find out if you collect a brick sample from the furnace, you can find there are different zones, like the slack surface, decarbonized or original. The more it is there, it is better. So this is the antioxidant, and you can get the HOR about more than 120. And we have done some study on slack, because basically it's a monitoring of slack. So the slack should have the following properties like the low melting, low viscosity, low surface heightening. And we have done some phase diagram study. And in this phase diagram, we could find out that if you can produce tricalcium and dicalcium, the melting point is 1990 to 2030. And there, if you have the calcium ferrite is 1216, or fluorspar, what we are adding for fluid, it is 1340. So we have to avoid all these things. For converter, we need magnesium oxide. That is the phases we have to get so that you can better life. But we have done again some slack coating, slack sticking, because basically we have to give a good slack coating. So we have to think, we are making a bricks having good permeability, so that we get a good slack sticking, and that's how we can develop the slack. This is another important is the MDO saturation. Depending on the basicity of the slag, whether it's a silicon killer, the aluminum kit. So what we have designed the refractory so that you have a less saturation. For converter, basically more than 3 you get only 6.5%. And if ladle actually if it is less than 2 you get more, about 12%. And this is basically and for that saturation, because steel making is nothing but the slag making. So you should have a good line. That is basically the low LOI and high reactivity. Reactivity more than 300 and dolomite also the same. So we have developed a slack modifier, because if the slack is not in a position to give you the proper reactivity and making slack, so this is a briquette form. What is basically when you charge this briquette into the steel, it is going into the main, and then it is because of the buoyancy effect, it is making a foamy slack, and that is coming out and giving a very good slack putting what in the lateral lining or the converter lining, and that how we are getting. This is the property of the bricks. And I'll just take 1 minute. This is about the lining design of ladle, where the back field mass is very important. And this is basically we have to go for a jointless lining. And this the thermal profile is again very important, because the cell is hitting faster than lining. So you have to maintain a thermal profile. And this is the preheating schedule, and this is what is converted having different zone. So and how different zone. So with this. Now, I thank you very much for giving me this opportunity for sharing with you. Thank you.
Thank you, sir. I will now invite the team from NIT Raipur to make their presentation, please. The next presentation by team of Bhilai, Shri Ashish Mishra and Madam B. Anwar.
Ladies and gentlemen, myself, Mitra Anuradha from Bhilai Steel Plant Environment Management Department, with my colleague Ashish Mishra, PhD scholar from NIT Raipur, here to present a paper on basically a utilization of the LD slab in road making, slab, paver block, everything. कहानी शुरू होती है मई के महीने में, जब भिलाई स्टील प्लांट से 4 लोगों की एक टीम रांची से एक्सपर्टीज लेने जाती है कि हम एलडी स्लैग को यूज करके पेवर ब्लॉक कैसे बना सकते हैं। तो जनाब एलडी स्लैग से यूज करके पेवर ब्लॉक बनाने की जरूरत क्यों पड़ी? तो वो इसलिए पड़ी क्योंकि स्टील इंडस्ट्री सीपीसीबी और एमईओएफ की लिस्ट में, मिनिस्ट्री ऑफ एनवायरनमेंट एंड फॉरेस्ट एंड क्लाइमेट चेंज की लिस्ट में उन 17 मोस्ट पॉल्यूटेड इंडस्ट्रीज में से है जो बहुत ज़्यादा पॉल्यूशन क्रिएट करने के लिए जानी जाती है। और जब हमने 7MT एक्सपेंशन लिया था तो हमारे कंडीशंस में ये बात थी कि हम 100% सॉलिड वेस्ट यूटिलाइजेशन करेंगे। तो श्री तापस दास गुप्ता साहब के मार्गदर्शन में 4 लोगों की टीम रांची गई थी, और रांची से आने के ठीक 19 दिन के बाद हम लोगों ने एलडी स्लैग से पेवर ब्लॉक बनाने का सेल ग्रीन टाइल्स प्लांट के नाम पे आरएमपी 1 में हम लोगों ने एक प्लांट लगा दिया था। ठीक 19 दिन के बाद इसका इनॉग्रेशन हो गया था और फुल जुगाड़ नीति से हुआ था। एक भी आइटम बाहर से नहीं खरीदा गया था। जो हमारे प्लांट में जिसको आप स्क्रैप करके फेंक देते हैं उसको ठीक करके हम लोगों ने इस प्लांट को चालू कर लिया था। और मेरे ख्याल से ऐसा बिजनेस यहाँ बैठा हुआ हर शख्स लगाना चाहेगा कि जब हमारा माल बनता नहीं था और कस्टमर हमारे गेट के बाहर खड़ा रहता था कि सर दे दीजिए, उसकी एक्सेप्टेबिलिटी इतनी ज़्यादा थी, चाहे वो आरएमपी 3 हो, चाहे वो ब्लास्टरनेस 8 हो, चाहे सेक्टर 9 का जो पार्किंग लॉट है जब वहाँ पे लगा हुआ हो। हम लोगों को क्यूरिंग करने का टाइम नहीं मिलता था। हम लोगों से ये बोला जाता था कि साहब आप मटेरियल दे दीजिए, हमने ट्रक लगा दिया, क्यूरिंग हम वहाँ पे कर लेंगे। तो इतना प्रॉफिटेबल बिजनेस हम चला रहे थे। तो बहुत लाजमी सा ये सवाल है कि आप मुझसे ये पूछेंगे कि मैडम जब आप इतने प्रॉफिट में चल रही थी तो आपको एनआईटी रायपुर के साथ क्लब करने की और अपने बिजनेस को एक्सपैंड करने की आवश्यकता क्यों पड़ी? तो यहाँ जितनी भी खूबसूरत महिलाएं बैठी हैं उनकी तरफ से मैं एक भी पुरुष यहाँ बैठा हुआ एक भी पुरुष मेरी बात को काट नहीं पाएगा कि हम एक ऐसे देश में रहते हैं जहाँ की महिला एक ऐसे साड़ी की दुकान जहाँ का महीने का टर्नओवर 1.5 से 2 करोड़ का होता है, वहां से 3 घंटे की परचेसिंग के बाद ये बोलते हुए निकल जाती है कि मुझे इस दुकान में कोई साड़ी पसंद ही नहीं है। तो आपको ये मानना पड़ेगा कि आपको अपना बिजनेस चलाना है तो आपके पास 10 आइटम होने चाहिए बिजनेस को दिखाने के लिए। तो उसके कारण हम लोगों ने रायपुर NIT के साथ एक प्रोजेक्ट MOU साइन किया, जिसमें हम लोग पेवर ब्लॉक के अलावा और भी बहुत सारी चीजें बनाने के लिए अपने आप एक्सप्लोर कर रहे हैं, ताकि हम उसमें मिक्सिंग रेशियो को चेंज करके शेक डाउन प्रॉपर्टीज को लर्न करके हम हमारी जो वैरायटी है हम उसको बढ़ा पाए। तो कोई आश्चर्य मत करिएगा कि अगले बार जब आप सेमिनार में आए तो एटमॉस के बगल वाला जो स्टॉल होगा वो हमारा होगा, और आप कभी भी यहाँ से 1700 किलोमीटर दूर भी आप कभी कोई दूसरा सेमिनार अटेंड करने जाएंगे और मॉर्निंग वॉक में निकलेंगे तो नीचे जो आपके पैर के नीचे जो पेवर ब्लॉक आएगा वो भिलाई स्टील प्लांट के एमटी स्लैब से बना। ये मैं आशीष मिश्रा से रिक्वेस्ट करती हूँ कि जो शेक डाउन प्रॉपर्टीज है वो आपको एक्सप्लेन करें, ताकि आपको हमारी जर्नी के बारे में थोड़ा और समझ में।
Thank you, ma'am. I am thankful to Bhilai Steel Plant, Tapas sir, and my supervisor, Dr. Sunny Deol, NIT Raipur, for giving me opportunity to perform experimental work and find out the boon or the advantage of using steel slag in pavement application, in flexible pavement as well as in rigid pavement, that is CC roads. So I have validated 2 strength properties, that is characterization of its shakedown properties and find out how it is environmentally better to use. So first of all, this is engineering property, that is shakedown. It means that whatever the stresses coming to the aggregate, it is makes the aggregate in a stable condition, and if the load exceeding the stable limit, it converts to elastic strain to plastic strain, so that the curve shifted to elastic strain to plastic strain. Plastic strain is nothing but the plastic shakedown limit. So we have to test the strength characteristics of the aggregate before using it in a base or sub-base layer. That is the base or the foundation of the road. So I have validated its properties. These are the previous literature works that satisfies the permanent deformation of the aggregates in 5000 to 3000 load repetition, whatever the plastic strain should come to the aggregate. So we have tested the properties of conventional aggregate and steel slag. These are the basic properties, these are the strength properties, these are the chemical properties, these are the raw steel slag image, and this is the microstructural property SEM image. This is the particle size distribution of study material. We have collected steel slag from different depth that satisfies different ages, that is less than 1 year from the top layer, then beneath 5 meter we got 1 to 10 year old steel slag, and after 5 meter we get greater than 10 year steel slag. So depending upon the age we have categorized the properties. This is cyclic triaxial test. With the help of this I have applied different deviatic stress with a constant cell pressure. Cell pressure is nothing but whatever the confining pressure coming to the aggregate or the material, and deviatic stress, it is the repetitive traffic load which definitely come on the aggregates which is used on the pavement. So these are tested in 3 moisture conditions. OMC is nothing but optimum moisture content at which we are making the roads or we are making the materials to be utilized. And OMC -2 and +2% means if it comes in the contact of rain, whatever the swelling nature, whatever the wetting properties we have defined by increasing the moisture content 2%, and OMC -2% means if it is tested in the dry condition, whatever the property it is giving. These are the properties we have got after testing. We got the results like, as we increase the moisture content, the plastic deformation on behalf of the increasing load increment, it increases. Because in steels like we have vesicular nature, just like pockets in that, it has the ability to absorb more water, and it is the property, that's why the permanent deformation increases. This is tested at 20,000 load cycle. Next, this is tested at 30,000 load cycles. According to ASTM code, we have applied 10,000, 20,000, 30,000 load cycles, and we have categorized this permanent deformation curve. This is the nature. If we are testing at the optimum moisture content, what is the effect we increase the stresses? So we have tested at a constant moisture by increasing the deviatic stress at 350, 450 and 550 kilopascal. This is the 30,000 load cycle. We have tested a single sample by increasing 10,000 load cycles. So this is the nature. On 10,000 load cycles, it follows elastic strain and it comes in range A or B. But as the load repetition exceeds to 20 to 30,000, it comes under the range C, that is incremental collapse. This is the resilient modulus test results. Resilient modulus is a property of the material by which it takes the load and it defines its elastic limitations. This is the principle of the shakedown characteristics. We have tested the material, and according to its plastic deformation curve, where the performance or curve is changing, we have plotted tangent in that and we have marked the positions. So according to which we are marking as range A, B and C. So we have tested 3 gradations of each material, and we have defined that what the shakedown characteristics it follows at different load cycles. So the results are, we have tested at 10,000 load cycles. The permanent deformation varies from 0.61% to 2.8%, and the better performance characteristics gradations are HM2, G3, and the maximum permanent deformation came for SSG1. Similar results came. Next. This is the results of effect of deviatic stress. If at constant moisture content we increase the deviatic stress, the better performing gradations are HM2 hybrid mix 2, and the minimum performing material at corresponding maximum permanent deformation for SSG3. So we have categorized the engineering property, then we gone for environmental characteristics. So we have tested for GWPI, that is global warming potential index, that which mixes are performing structurally better and which mixes are performing better as environmental point of view. So we have calculated CO2, CH4, N2O, and we have made a 1 kilometer stretch and used that material and tested that what carbon emission that materials if we use for a 1 kilometer stretch, what quantity we are using, then how it environmentally degrading. So better performing results are hybrid mix 2, just like 54.37 kg GWPI it is performing. Next. So the conclusions are, whatever the materials which are coming in range A and B are viable to use in the pavement construction, and whatever the materials going for range C, it is incremental collapse. It will collapse after a particular load repetition. So this is a material characterization tool by which, by performing laboratory characteristics, we can define its age limitation or we define its performance to the field study. Next. Thank you.
Thank you, ma'am. Thank you, sir. Shri Khileshwar Kumar has now joined us from NIT Raipur. I request him to make his presentation.
Good afternoon to all. I am very thankful. I am here to present. I am very thankful to organizers for giving me opportunity to present my paper, automatic detection of the surface defect on the rolled steel using the deep learning technique. Today's agenda is introduction, idea behind this work, and literature survey, method and materials, result and discussion, and the last is summary. First, the introduction. What is the surface? What is the surface defect in the rolled steel? The imperfection that occurs on the surface of the steel during the rolling process is known as the surface defect. It may be different type like scars, holes, bubbles, inclusion, iron oxide scales, roll printing, edge cracking, and scraps. The main idea behind this work is that can artificial intelligence automatically classify and detect the surface roughness. Previously, the surface defect is identified by the measuring instruments and the operator. This may be a problem of insufficient inspection, unreliable inspection data, and no digital data. So we have proposed a algorithm to automatic image acquisition, and the algorithm that will be work and detect the steel surface that classify that the surface is defected or not defected. So based on this, some previous work already has been carried out by the different authors. In this work, first paper is deep learning transfer, deep assemble transfer learning based approach for classification hot rolled steel strip surface defect. In this work, two CNN work like mobile net and the exception was combined to use the classification of the six different type of the steel surface defect. In the next work, a deep learning technique was used to detect the surface defect. This work was actually compared with the YOLO V8, which and this work you can see that in this work the mean average precision was 0.7. So for improving the accuracy, we have proposed a algorithm like in this work a new surface database was used to detect and classify the surface defect. In this work 1800 sample images was collected, and in this work crazing inclusion patches, pitted surface, rolled in scale, and the scratches. Six different type of the surface defect was considered, and in this work also detectron 2 architecture was used. This deep learning technique actually based on the two category, and this is the first is the backbone network and second is the region proportion network. First backbone network is to obtain the features, and second is used to that features for the detection and classification of the surface defects. So based on this algorithm, I have obtained this evaluation result. The average precision of the different surfaces we can see that the average precision was for grazing is 37.17 and treated surface is 67, and inclusion for 76.548, and rolled in scale for 75%, and patches is 64.95%, and for scratches is 84.64%. As from the literature, we have obtained that this is the best result from the this is the object detection, and this is the object original marks as can be seen that in the above images. And first is the patches scratches, pitted surface, and inclusion. This is the masked by the manually, and this is the below side images. You can see that this is the work by the algorithm, and which is then predicted by the detectron 2. In some of the cases, like in the pitted surface, the accuracy of the prediction was 86%, and but some of the areas is not has been captured by this algorithm. So we will improve this in the further works. And the final conclusion was the average precision and AP 50% and AP 75% computed on the value of 0.70% and 75%. And the proposed model was not correctly able to identify the grazing surface. In this case, the average precision was 0.37, and the last, the model accurately identified the patches, scratches, and the pitted surface, and the inclusion type of the surface correctly. Thank you.
Thank you. Now we'll break for networking tea for 15 minutes in the PD lounge downstairs. Our presenters will also be there, and if anyone has any questions, they can ask them in the networking tea session. Thank you.
Good evening, all the dignitaries. I am Rahul Kumar Soni, a senior scientist at CSIR Institute of Minerals and Materials Technology, which has been introduced recently by my colleague Dr. Anil Kumar Chobe. I believe I have been allotted the last presentation for this conference, and I can understand after the last 2 days of hectic brainstorming, you might have been tired. So I will quickly go through the slides without taking much time. And if anyone interested, you can have the personal one-to-one contact and further discussion. This work is being done in joint association with IIT Bombay. So, coming to the problem statement first, we are all belonging to steel industry, and we understand that primarily we get a raw iron ore, which is of like medium or high grade, 50% or something, and then we are supposed to calibrate that to 62+% so that it can be subjected to blast furnace. Now the problem is that this high grade or medium grade ore is not going to be there with us forever. Ultimately we have to deal with the low grade ores, and these days Government of India is mandating to use these low grade ores, otherwise environmental clearances and all those issues are there. So, but the problem is that with Indian low grade ores, we are having a significant amount of goethite, limonite and siderite, which are basically the hydrated and carbonated forms of iron ore, which are basically having the characteristics of clay kind of nature. And because of this kind of low grade ores are not responding well to conventional mineral processing operations. These clay materials are creating flowability issues, and because of that, those instruments are not responding. Further, this goethite, limonite, these kind of materials are of soft characteristic. And hematite and the other primary ores are of hard characteristics. So because of which this is causing issues in the grinding. Ultimately, we are getting a wide spectrum of the product size distribution, and the energy cost is high in the grinding. And we know that in the mineral processing plant, grinding is the major energy consuming unit operations. Further, even if we try to do somehow, then also we are not getting the target of alumina and silica content in the final ore. So what we have been trying, actually this process has been tried and tested very well in other countries, primarily China, but we are refocusing this process with Indian ore characteristic, which is different obviously from the other countries. So conventionally what we do, okay, anyways, so conventionally what we do in a blast furnace or any other furnace, we use hematite directly to metal iron. But intermediate products are magnetite and bauxite, and many other phases are there, but these are the primary phases. Somehow due to temperature and gaseous concentration, these spaces are not stable, so we are not considering. But when we try to apply this process to low-grade ores, it is not responding. So what we are suggesting and trying is that we do the control reduction up to magnetite, so that magnetic susceptibility of this material is increased significantly, and we can do the magnetic suppression. So the load on downstream operations are also low, and due to magnetic properties, and if we are doing the high temperature operation, porosity is created, because of which grinding is also easy and less of energy. There are many advantages of this process. Process is of low cost, and most important thing is that after adopting this kind of process, we are able to deal with the low grade ores, which is a main problem nowadays. So, CSR have been long working on this technology, and we have tried different reductants like coal, coke, pet coke, even cow dung and biochar for this kind of process, and it has been reported well in the literature. We have found that with the increase of temperature and this reductant concentration, we are getting good results in terms of Fe grade, high grade, and recovery. But the problem is that when we are dealing with the lump ores, this process is okay, but when we are dealing with the fine ores, which is a good resource of low grade ores in terms of slimes, tailings, and previous discarded ores, which are primarily in the form of fine particles. So at that moment, what happens? We face the problem of over reduction. So instead of the material getting stuck at magnetite, it is over reducing to bustite and metal iron, which is causing a significant loss of Fe in those forms. So we have been trying to optimize this process, and I have used modeling and simulation for this work, followed by the experimental validation. So we have applied all these mathematical models for cluster diagram, phase diagram, and we know that for temperature and gaseous concentration we will get the maximum amount of magnetite. After doing the yes, so these are some of the we are doing the fluidized bed reactor. So these are some of the elevations. Yes. So this is the main result for us. After doing the optimization, we have found that around 20% carbon monoxide concentration balanced by rest, carbon monoxide or nitrogen. Around at this concentration, we are getting the best results. Around 99% conversion of hematite to magnetite is happening. Only less than 1% over reduction is happening. But again, after doing all this exercise, the end result is that where from we will get this carbon monoxide. Again, after burning the fossil fuels, and which have been discussed in last 2 days, we are supposed to go for decarbonization. Yesterday, Prakash sir also said that. We have to first try to do the research, and then later we can see where from all this hydrogen resources will come. But after doing a lot of literature work and research, I have found an interesting thing that blast furnace flue gas, the composition of this gas is around 20 to 25% CO, hydrogen 2 to 5%, balanced by nitrogen, CO2, and H2O. Now the GCP value of this gas is very low, 600 to 700 kilocalorie per meter cube, which is equivalent to a very bad grade coal, and that's why it is considered as a secondary fuel in this list. Somehow we are mandated not to leave this environment, so we are burning as a secondary fuel, and like GCP process we are treating. But for our process, this concentration is excellent, so it can be like gold for this process, and we don't require any additional coke or fossil fuel for this kind of process. We have been doing experiments with blast furnace flue gas artificial combustion. We are getting very good results on time on this one. So this is the primary conclusion from my work. We are trying to get an alternative source which doesn't require any additional fossil fuel consumption. This is the last slide. So thermodynamics of the process also says that, because these questions are asked later, that the entropy value, its free energy value, and enthalpy change, all are in favor of spontaneous reaction. So this reaction only requires high temperature to be maintained, and I have done some calculation, I am not showing here, that the blast furnace flue gas, whatever is being produced, that is in the enough quantity to raise the temperature and perform the reduction. So right now there is another project where I am working to converse the gas and use as reductant at the same time. So that work is being done. Thank you.
For Q&A, so I request audience to raise their hands if they are having any questions from this session. Anyone? Thank you, sir. In this session, we are having no question. Now we move ahead with the last presentation of today's session from RT Group. I request Mr. D.S. Narayan, sir. Please come on the dais for his presentation.
Gentlemen, this is the last paper. I hope you give me some time to explain what I wanted to say next. See, in this world, there is nothing free except two things: mother's love and then the nature's abundance resources also comes free of cost. Among the resources, today only air, wind and ocean currents are available to you free. Water was very free until recently, but now because of decreasing resources, we have to pay for the water too. So now, cost of air, Mother Nature is failing in its to meet the ever-increasing demands of humans' requirement for clean air. Ever-increasing human demands for pure oxygen in the area while killing and smothering all plants, the only source to maintain the oxygen balance in the atmosphere. No reciprocity to give back to Mother Nature what was plundered and being repeatedly unabased. See, for example, in the mines, you take out the material, but there is no system to replenish what you have taken out. You have taken out the oxygen, but there is no system to give back the oxygen. So this is what is called plundering of the nature, and nature has its own balances by having plants which are the only source to give back the oxygen. So oxygen is critical for humans and used unabatedly for burning carbon and generating carbon dioxide and depleting, protecting ozone layer. Now, by depleting the oxygen, not only you are affecting the your ability to breathe properly, but also the ozone layer, which is protecting us from the UV lamps, the UV rays, also is being affected because of the depletion of the oxygen. The time is not very far when quality air will require for breathing will also have to be paid. This is not very far. Maybe very shortly you will also have to pay for oxygen, and that is happening in many countries, in advanced countries. So they are very, very concerned that we have to take immediate and urgent steps to stop this degradation of the environment. Next slide. The steel makers' role in sustainability. Current steel industry trends. Ores are mined without a thought of replenishment. We mine all the ores, but you be sure it's not being replaced. Because once it's replaced, once it's mined, it's gone, and you go to the next mine and again take it out, and again not replenish it. Profit motive is the only driver while setting up a new steel plant process. And presently, the exploiting oxygen from Mother Nature without plans to return it. The mining, the coke ovens, blast furnace and BOF route of steel making is not an environmental friendly process, but it is the dirty steel making process as the app names. But today it is the only profitable method of making steel, so people are going through this route. No plans on the horizon to meet the goals of sustainability. So once you are not able to sustain, what do you mean by sustain? Means you take and give. Give and take is not there. Those plans are needed to use green energy, green hydrogen, and to make green steel for sustainability. Next slide. Now, what is green energy? We get green energy from sunlight, wind, oceans, and green hydrogen is made from the electrolysis of water using renewable energy sources. The renewable energy sources are three, that is wind, sun and oceans. Next slide. The green steel is made using green energy and green hydrogen. The green steel currently not very profitable, but needed to maintain the balance of Mother Nature. Ores upgradation and reduction with hydrogen. This is important because the ores which we get from the lines, I have read this in detail in my paper, which is maybe there in your books. So how the ores has to be upgraded at the mine head, so that we don't carry all the dirty ore up to the plant and then again generate this slag and scrap. But the ore has to be upgraded so that we get higher metallic content. The second, ever increasing scrap recycling and improving the scrap recycling process. Melting in EAF using renewable energy. Reducing with hydrogen wherever needed. This would be an ideal environment friendly process for green, iron and steel making. Next. I think that's all I want to tell you about it, because this is a very high concern, but nobody has addressed the position of the oxygen depletion, which is not easily renewed. Only we are talking about carbon. Of course, it has a harmful effect directly, but oxygen depletion also is a cause of very big concern, and which has to be also addressed in a very urgent and emergency manner. Thank you very much.
Thank you so much, sir, for sharing it. Sir, please be on dice, sir. If anyone having any questions from this session, they can ask. Please raise your hand.
Right now is all theoretical. We have to achieve this. Nobody has achieved that except maybe SSLE has done shown that this is an industrial green steel can be made. That's all. I think one plant has shown that, and I think it will follow very strongly. All of them have no option.
Thank you, sir. Thank you, sir. Das Gupta sir want to ask some questions.
Sir, anywhere you have already started that green steel production?
Which one, sir?
Green steel production.
Yeah, SSAB, you must have read it in there. They are the only plant to set up a green steel production, and they have shown that industrially it is possible to make green steel. But it requires legislative support of the government to ensure that the dirty steel is taxed highly, green steel is taxed less. That's the only way to do it, and it is done in EV, electric vehicles they are doing it. Something similar has to happen to make a green steel a viable proposal. Today it is expensive, but I am not.
Where they are commercially making?
SSAB Sweden.
Sweden.
Yeah.
In India there is no.
They have already started and they are running it because we are aware of that, and they are making this steel in industrial grade, not in the just pilot plant stage, industrial level.
Yes, nice.
But they are using scrap.
What is the extent of, what is the quantity that they are producing? Because so far I know, everybody is claiming but nobody is practically showing.
No, SSAB is very special steel maker, you must be knowing that. They make very special.
No, but I want to know the content, quantity, how much they are doing. Theoretically everybody is claiming we are doing this, we are doing that. But in fact, everybody is only transferring. EV vehicle, EV vehicle, okay.
Let us hear one thing. Maybe it's 1 ton or 100 tons or 1000 tons. But awareness that we have to make green steel, that is the point of my submission.
Okay, agreed.
That is all. So the question is already, one company called SSAB was well known. I think 2 years back they started making a big noise, and we went there. One of their furnaces is 60 tons. So we know that because one of our partners was there to do some commissioning. So we knew that this is working. So the question is, they are all still continuing to make this, but they have a very high degree of support from the government, which gives them the tax breaks and gives them the legislative support to ensure that green steel sells at that price which is acceptable.
See, there is no doubt that we have to accept this fact, but the problem is that wherever people are doing anything, nobody is transparent about doing what they are doing exactly. Everybody is talking more about it than showing the whole world how they are doing. So I am very sorry, this may sound very harsh, but so far with my experience of say 1 year, I have been thinking, talking and listening about it, but I haven't got anything very clear. Wherever people are doing, see, I have been to GAT, ArcelorMittal, They said they are doing hydrogen injection. I asked them how you are doing. Then they said that we are actually working on a pilot project. So see, people are talking more about it than being transparent on it. That's the biggest problem that the world is having today. Everybody is talking more about it. Yes, it's a fact.
Sir, let me tell you
it's a fact.
one thing is there very sure. People are secretive even in the current technology of BOF, BF and all that such mature technology. It's been around for decades. But still people say you should not visit my plant, you should not take photographs. They think that they are still having a secret. There's nothing secret about it. Every plant knows what's going on. But the question is, this is the what you call a business model. But everybody has to help himself to get the business going as we want. And this particular pressure on us to ensure that the environment is not degraded, it is going to be very, very serious in short time, because already it is being felt very badly in Europe and other countries, because they also have a lot of problem of the temperature, because of which all these polluting industries cannot work. They cannot function in those climates, because they have a breathing problem, they have a lung problem, they have all sorts of diseases. So pressure on those countries are very high, and will not be far, we will also have pressure. So the pressure is already felt in China, where already they are suffering from excess capacities, they are not able to sell, and also in some of the places the pollution is terribly high, so they have to close down some of the units. And they have closed down all the polluting industries. They think now they are efficient, but still they have this oxygen problem in many places. So, I mean, it is a global problem. We have to think globally, and if you can solve it and you can take emergency step to address this solution, we will have a solution. And I am sure our minds are not less. We are much better than any other foreigners or Europeans. We don't have to look outside. We can look inside only. We have got very high degree of technologists who can address this problem much better and adapt to our Indian conditions than even say look for technology outside.
Thank you very much. Discussion on it can go for hours together. So let's just make a stop at it.
Thank you so
Don't forget to like, subscribe and share the videos.